So today, again, parallelogram. So what we're trying to do today is prove something is a parallelogram. So it is the Common Core is G for geometry, CO for congruence, and is number 11, which is proving theorems about. Now it's going to say polygons, but we're going to specifically say parallelograms because that's what we're talking about today. So I'll say parallelograms. I'm missing parallelograms. Parallelograms. I'm missing a word. I'm missing a. Yeah, that's right there. Parallelograms. There we go. So let's go ahead and take a look at it. So is it a parallelogram? Sure looks like it, right? Sure looks like it, but how can we prove it? So if I plug in the numbers, right? If I plug in the numbers, and this side is equal to this side, if I plug in the numbers and this side is equal to this side, then it's got to be a parallelogram, right? So let's prove it, okay? So first of all, if x is 7, let's put in 7. Let's put in 7. So 3 times 7 is 21. 7 plus 14 is 21, okay? Opposite sides are equal so far, right? So I just plugged in my 7 and plugged in my 7. Now let's plug in the 4. If y is 4, let's plug in the 4. So we're going to go 5 times 4 minus 4. 20 minus 4 is 16. We'll plug in the 4 here. 2 times 4 is 8. 8 plus 8 is 16. So our opposite sides equal 16. 16. 21. 21. Yes. Yes, it's a parallelogram. Okay, so we can say yes, it is a parallelogram. And we're just going to simply say because opposite sides are congruent. It's one of our conditions, right? It's one of our conditions that we looked at in our reading. Okay, that was pretty easy. So then, let's take a look at number 2. Same thing. So either opposite angles have to be equal, or because we're talking about angles, or they have to add up to 180. So let's check it out. Let's put in 11. So 9 times 11. Let's take 11. Let's plug 11 right there for z. Let's put 11 here for z. Okay. So 9 times 11. Let's see what's that. 9 times 11. 9 times 11. Plus 19. That's what calculators are made for, right? Let's check it out. 9 times 11 plus 19. 118. So that means this angle's got to be 118. And then I'll put it in here. I'll go 11 times 11 minus 3. Okay, what is 11 times 11 minus 3? Okay, 11 times 11 is 121 minus 3, 118. Okay, good. So here's what I know so far. I know these two angles, opposite angles, are equal. But now I don't know anything about this angle here, right? But maybe I can get an angle here that would help these add up to 180. So let's check it out. So let's put in the 4.5. So if W is going to be 4.5, let me put 4.5 right into there. Okay, so let's go 14 to my 14 times my 4.5 minus 1. Use my calculator. So I'll go 14 times my 4.5, subtract 1, and I get 62. Okay, so now, what am I looking for? I don't know what this angle is here, but I do know if I could add these up. In fact, if I add them up, what do you know? It adds up to 180. Okay, that's good. So if they add up to 180, and if I add these two, they add up to 180, right? I could find this other angle, which turns out to be 62, so I can say yeah. And so we're going to say yes, it is a parallelogram. That's a parallelogram because consecutive angles are supplementary, right? Got it. Capiche? Pretty easy so far? Okay. Example 3. So, let's see. I've got something about angles here maybe. and opposite sides. So let's plug it in, okay? So is a parallelogram? I don't know. 2.4, let's put the A in here for 2.4, and we'll put the 2.4 into here. So let's see what's 7 times 2.4. I don't know. 7 times 2.4. And what's that on my calculator? I don't know. Clear. Thank you. 16.8. So I know that this side is a 16.8. If I put in the same thing over here, plug in my 2.4 into here, what is 2 times my 2.4 plus 12, okay? What do I get?
16.8.
16.8, okay? All right, great. Now, let's try out the B. Let's put in the 9, okay? How am I doing? Put in the B, put in the 9 here, and put in the 9 there. So, we're going to go 10 times 9 minus 16. What's that, Katie?
74.
Thank you, Katie. 74. And then we'll plug it in here. 9 times 9 is 81. Plus 25. I don't know. I'll have Katie tell me what it is. 9 times
106.
plus 25. You got 116.
106.
106. If I add these together, it makes 180, right? So, is this a parallelogram? Well, the problem with this one is everything works. It all adds up, but is it one of those? This one's definitely got a problem, because is it one of our things from our reading? Is it one of our theorems? So, let's check out our theorems from our reading. Let's see. Where did I put my... oh, here it is. So, let's take a look at it. What do we have? We have one pair of consecutive angles and one set... But I don't think that's on here. I think what we have works, right? But it's not there, right? It's not one of these. So it's kind of like being a lawyer in a court of law. You might have something you think is true, but if it's not one of the laws, does that make sense? If it's not one of the laws, it won't work. So what we have here isn't enough to prove this is a parallelogram. I mean, it's got some stuff, but it's not enough. So we're going to say, not enough information. Not enough information. What I would need is maybe another angle, right? Or the other sides to make it work. But that's not enough information. So I'm like, bummer, I did all the work, and I don't know if it's a parallelogram, right? Okay, you ready to turn the page? Everybody good?
1 second.
Jade and I always impatient, man, am I? Right? I don't mind. Got you covered. Always. Okay, there we go. All right, now, this is kind of like our warm-up. So, if it says show, we're going to prove it, but we don't need to do a proof with 2-column statements, reasons given, blah, blah, blah. Let's just do this one by proving what a parallelogram is. Okay, so let's graph it, okay? So right off the bat, let's go ahead and put down our points. So we're going to be at -3, 2. There's A. -2, 7. 1, 2, 3, 4, 7. Okay. 2, 4. 1, 2, 3, 4. And then 1, -1. There's D. Okay. Go ahead and draw it in. Alright. How am I doing? Now, let's take a look at what we have, okay? Okay, ready? So we have to prove it's parallelogram with one of these. Either we got to show that sides are equal length and opposite sides. I have to do that. Or opposite sides are equal, or opposite angles are equal. I got to do this supplementary thing or something with the bisectors. And there's one other. That's its definition. It's just plain old definition. So what do we know? What's the definition of a parallelogram? What's the definition? Yeah, opposite sides. So, being that I'm a little bit smart, on some days, when I get enough sleep, I either have to use I have to use one of these, right, or its definition. Now, of course, I'm thinking, wouldn't the definition be the easiest? Why do I think the definition is the easiest? Why do I think the definition, out of all these ways to prove it, and they'll work, why do I think the definition is the easiest? I get the slopes. The others require me to either find some angles, which that's going to be hard because we don't know anything about trigonometry yet, or I've got to figure out the lengths of these, and that means like Pythagoras theorem, which I could do, right? But why not just the slopes, right? Just like we did in our warm-up. So for me, the easiest way is to prove it by finding slopes, right? And I'm not saying that you can't use any of these others, but doggone, let's use the easiest way, right? So if I did that, let's find out the slope of AB. So AB, the slopes of AB is up 1, 2, 3, 4, 5 over 1. Hey, I think the same one we did on our warm-up, isn't it? I do that sometimes, don't I? Let's find the slope of DC. Slope of DC is up 1, 2, 3, 4, 5 over 1. Okay, so now here's what I know. I know AB is parallel to DC. I know that. I just proved it. Same slope, right? Did that. That's easy. So then, what about the slopes of BC? So BC, slope of BC is down 1, 2, 3 over 1, 2, 3, 4. So it's down 3 over 4. And the slope of AD is the same thing, down 3 over 4. So I can say that BC is parallel to AD, right? So I've got it. There's my proof. And the last thing I'm going to do is just say it's a parallelogram, okay? So the last thing I'm going to say is that ABCD is a parallelogram. Oh, 1R I need more sleep. Parallelogram because opposite slopes are equal. Is that better than doing the old 2-column statements, reasons, given, blah, blah, blah? Not a much easier way to prove things. Okay, here's what I want you to do. Okay, page 42, 9 to 23 all. We've got time. Yeah, we got time. 44 and 45. Nicole, give me your phone, please. Thank you very much. Okay, so let's get started, you guys. And I'll stop recording this.